Clamp the tail steadily in a slant upward direction. Push and pull the rod continuously for 3 to 5 times to discharge the oil in the solenoid valve. Vent the air at the tail. The positioning clamp must be centered exactly above. Use special positioning drills and positioning tools to drill to the specified depth. At this point, it has not been drilled through yet. Then use the specified drill bit to drill through and release the air. Note, it should move vertically up and down according to the shock-absorbing plane and must not be skewed. Use a drawing machine to press the guide down. The clamping plate being used now is to control the left-right skew of the movement. It should not be clamped tightly, and a certain amount of space should be left. Lower the drawing machine to a height appropriate for the special tool. The special tool must be installed properly. Lower the machine body to make the special tool press tightly against the movement guide. Then use a jack to jack up the movement and push open the guide. Push away the jack, raise the drawing machine. Directly remove the movement from below, and remember to put the special tools back in place. Use a lathe to remove the protruding fastening points inside the barrel. Measure the position of the fastening points from the outside with a caliper. Press the tip of the tool against the mouth of the shock absorber cylinder and zero the x-axis. Press the tool tip against the inner wall of the shock absorber cylinder and zero the y-axis. Withdraw the cutting tool. Push inward starting from the 0 point of the x-axis, according to the depth of the fastening point measured just now. Keep the y-axis at 0, which represents the inner wall plane. Push forward, and all the protrusions inside the cylinder can be turned off. Use tools to create a chamfer, with the main purpose of scraping off iron shavings. Follow the procedure in the video. Use the drawing machine to pull the tie rod out of the movement. Pour out the waste oil, clean all components on the tie rod, and check whether the piston's Teflon is in good condition. Measure the guide accurately, then find the new guide. Use a rotary welding positioner to cut off the bottom of the shock absorber. Mark the alignment lines clearly. Paste the positioning paper to assist with cutting and welding. On both sides of the cutting position, use a chamfering tool to chamfer and remove iron filings while the workpiece is on the welding positioner. Use an air gun to blow out the air seal. Measure the size of the steam seal and replace it with a new steam seal ring. Pay attention! At this time, it is necessary to clamp it upside down and firmly, and pour approximately 1/3 of shock-absorbing oil into the steam chamber. There are two types of shock-absorbing oil. 137 red semi-synthetic with a temperature range from 27°C to 230°C, which is suitable for most regions. 175 blue fully synthetic with a temperature range from 48°C to 110°C, which is suitable for cold regions on the Earth. The choice should be determined according to the area where the customer's vehicle is used. Install the steam seal. Right now, there's shock-absorbing oil above the air chamber. Set the shock absorber upright, place a tube beneath it, and press downwards. First, expel the air from the air chamber, and then keep pressing until oil starts to flow out from the inner cylinder. At present, the tail part cannot be welded yet. Clamp the shock absorber upright and add oil to the inner cylinder of the shock absorber. Add oil until it reaches approximately the finger-marked position. Then, pull down the tie rod. The tie rod only needs to be lowered to the position of the buffer spring. At this point, after filling up the shock-absorbing oil, install the guide. Use a sleeve to install the guide to avoid scratching the inner oil seal. Install the guide to the pre-calculated fastening point position, which will facilitate the next fastening operation. Use your finger to press against the air seal baffle below and feel the downward extrusion force. Fasten the guide at the designated points first without welding the tail part. Prop up a jack underneath. This way, when shifting to fasten different points, there will be no need to realign. Use a position-changing welding machine to weld the tail air chamber. Wrap a wet towel around the upper part of the area being welded to cool down the shock absorber. This prevents high temperatures from damaging the air seal O-ring. Align the position of the welding torch with the pre-drawn alignment lines. First, make 2 or 3 spot welds to fix the position. Then you can start the rotary welding. During the welding process, it's necessary to continuously cool down the shock absorber. Use a watering can to drip water onto the wet towel. After the welding is completed, continue the cooling process. Brush off the welding slag. Since there was no bottom sealing just now, it is not recommended to strike the shock absorber. Now you can use a punch to lock the outer edge of the guide. Add nitrogen. Note that the gas filling port needs to be at the most centered position of the gas filling tool. The repair is completed. Remember to place the tail part in a bucket of water to check for air leaks. Finally, use a dynamometer to test the compression damping, recovery damping, and the dynamometer curve of the movement when it is not powered. Then use the dynamometer to test the compression damping, rebound damping, and dyno curves of the movement when it is powered on.